So maybe we can go to the next session on the new platforms. Actually, the new platform is more related on OpenNetLab topic. So actually, in the last Global Research Summit, we introduced the first version of the networking education with OpenNetLab. So I think today we will invite two professors, Professor Chen and Professor Tian, give the new talk on OpenNetLab titled Enhance Networking Education with OpenNetLab. The two professors actually, Tian is from USTC. Professor Tian received a bachelor degree in EE and a master degree in computer science from USTC, and the PhD degree from the Department of Computer Science and Engineering from the Chinese University of Hong Kong. And he joined USTC in 2008 and is currently associate professor with the School of Computer Science and Technology in USTC. And Professor Tian Chen actually is a professor from State Key Library of Novel Software Technology, Nanjing University. He also published a lot of paper in the top tier conference, including CCOM, NSDI, and FAST. And he was the winner of Best Cooperative Professor Year of 2020 award by Huawei Central Research Institute. And by the way, Professor Tian Chen is the chair of the community of the OpenNetLab community, and Tian is the general founding member of OpenNetLab community. Yeah, let's welcome these two professors to give the talk on OpenNetLab education. Thank you.
Hello, can you hear me? Hello?
Yes, yes, we can hear you.
Yeah, you can hear me, okay. Thanks for introduction. So I'm the chair of the OpenNetLab, and currently I'm focusing on this topic, how to enhancing the network education with OpenNetLab. I have to focus on. I have to emphasize that OpenNetLab also encourages new research opportunities and provides the experiment platform. That's the next talk, which is from our Professor Chen from the CU National University. So in this talk, Professor Tian and me, we will focus on the networking education part of OpenNetLab. Okay. Okay, please next page. Hi. Sorry, maybe a little.
Yeah, Professor Tian, maybe.
Professor Tian, please help.
Yeah.
Okay. Okay. So this is a joint project between Microsoft, Nanjing University, and the University of Science and Technology of China. And in 2021, over 400 students in our two universities. Oh, it's okay. Okay. In 2021, over 200 students in our two universities, we are having networking courses. And in the whole China, there are over 3,000 universities in that we have not have computer science department, and they have computer networking courses in total. So we estimated that each year we have like hundreds of thousands students each year to having the networking course. Okay. So here is the problem. So in our I have been teaching this class, computer networks for like 10 years. This class is not suitable for pure online classes because there are a lot of contents. As we know, we have 7 layers, or we have 5 layers for the TCP/IP model. And each layer, we have quite different contents, from Mac layer to application layer. All these contents are really quite disaggregated. To have, if the students want to learn this course very good, they need to have hands-on experiments. Otherwise, I think if they don't have experiments, they will learn nothing solid. For example, in Nanjing University, we design a bottom-up experiment system from the Mac layer. We build a Mac protocol, and to the app layer, we build the application protocol. Finally, so two students can chat with text each other. So they build a whole system. But still, with this experiments is really limited for many concepts. For many concepts that is not available with our current devices. We have to resort to NS3 simulators, and even with the bottom-up experiments we talked about before, it's still we rely on virtual machines. We build virtual machines on students hosts. So and as we know, this is all these designs are mainly focused on classic topics like web, FTP, DNS, and TCP. These topics I say is classic and fundamental, but sometimes we need something new because these protocols are really, for example, TCP, FTP, are really decades ago. It's like dinosaurs from Jurassic Park. As we have seen from the previous talk, like the Victor and Kyle, they're from both industry and academia. The networking research is still very exciting, and we hope our students can embrace all these new technologies and the new hardwares. But this is really hard, in universities, the resources. The hardware resources are limited. We do not have too much money, and more importantly, the human resources is very limited. We do not have enough human to develop new platforms because we only have limited students, and they have their own research to do. So let's see, we have all these new networks and technologies like Wi-Fi, 5G, 6G, and Lily has just talked Starlink. We have Starlink, we just had Kai's talk, and we have new technologies like AI for networking for AI, and this is what my recent research focus on. But due to the large number of students, they cannot access this in the class, and we have zero trust networking on the firewall, something like this. Okay, we want our students to embrace all this new technology. That's our ambition. So with the emergence of OpenNetLab, okay, next page. Okay, with the help of OpenNetLab, we have an ambition that we can enable our students to access these new technologies and the new hardwares. And this community, I have been serving as the chair for over 2 years. This is a community for both networking research and networking education. It's founded in like 2 years ago. Now we have 12 members from across the Asia, and we have over 40 heterogeneous nodes and control frameworks. We have currently we have a free and public platform in the infrastructure, so we can do online teaching. Students from Nanjing University and USTC, over 400 students each year, are already using OpenNetLab for their online course and doing online experiments to gain a first-hand experience from real networking. Also, we have next talk. We have some professors doing real networking experiments over this platform. Okay. So in this talk, we will focus purely on the networking education part, and Professor Ye Tian have the details. Now I will give the stage to Professor Ye Tian.
Thank you, Professor Tian Chen, for the great opening.
It's too it could be louder. You tune the microphone.
Okay. Can you hear me?
Okay.
Yes.
So first, I briefly introduce how we taught the networking course in computer science department and EE department right now. actually, this course is hard to teach. We have an averagely lower remarks from the students than many other courses, because this course has many things to study, and sometimes these things are boring to study. For example, we have many knowledges from layer 2 to layer 7. There are many protocols, many devices, and many mechanisms. And most even worse, many stuffs, many knowledges are hidden in the OS kernels and device drivers and hardwares. For example, we cannot observe really how a router works in the real world. So there is little for students to play with. Students actually memorize and take the exam and get scores, but they have really bad learning experience. For example, actually, we have this course also have experiments, but these experiments can be categorized into two kinds. First is we ask students to capture some traces and analyze. So like we ask the student to use Wireshark to capture the traces. Second is we provide students some virtual environment to ask them to set up a simulated network and configure and observe how the network can work. So, so on the other hand, the network it evolves all the time. Network are more and more programmable. For example, we have the software open switch. We have the barefoot Tofino chip for programmable switch, and also have the smart NIC. Actually, for meeting the QoS requirements of the applications, this network must be more programmable to meet this requirement. And actually, our network education is not aware of this, and we believe we should prepare for this trend. And our key points is the students should implement rather than observe the core network mechanisms, such as congestion control or reliable data transmission. So our objective is to introduce programming to networking education. Actually, programming is the most important way to make students to really learn something. And for students, we encourage them to implement core network mechanisms such as congestion control or reliable data transmission or DNS. And for teachers, we want to enable them to quickly design and deploy course labs. So these are our two objectives. And the OpenNetLab is an ideal platform for achieve these objects because they have rich cloud resources, and they have real-world network impairments such as losses, latencies, and other things. And the platform is open and free. Everyone can can join this platform and contribute some resources and use resources from other partners. So we have built a system over the OpenNetLab. So the system currently is very simple. It has two kinds of nodes. One is a control node. This is this control node has a web portal, and it maintains user accounts such as teacher account, student account, and it has all the labs and submissions. Submission is the student submitted their code, and it detects and submits lab programs to the execution codes. We have the some execution nodes, and they coordinate the lab execution. So this is the controller node. And the second type of node is the execution node. This node executes lab programs submitted from the students, and it coordinates the execution nodes, executes the programs to exchange the messages and evaluate how the student implement the network mechanism. We'll have the example later. So the node communication between the nodes, between the controller node and the execution node is HTTP. It's simply the HTTP request and post. And between the execution nodes, we design a new protocol named the ONL protocol. So the online portal is over the top of TCP, and it has a few fields. For example, the experiment field, experiment ID, it has 8 bits. It specifies the ID of the experiment currently the data is about. And it also carries the student ONL ID. It is 16 bits. It identifies this data is from this student submitted code. And there are some other types. For example, this is 3 types. So with this protocol, we can multiplex the data to the appropriate Dockers for evaluate how the student can implement the NAP. So there are 4 types of users on our platform. The first is developer. The developer develops the new NAPs from the scratch, and it can release the NAPs and the Docker image. The second is the teacher or tutor. The teacher can configure the NAPs, and they can configure the parameter of the NAP and set up the evaluation rules. And it also can assign the NAP to the students and collect the evaluation results. The student can enroll a lab and complete a lab by submitting his code. And you can also view its evaluation results. And there are some, and the system administrator can manage the resource usage, including the CPU usage and the memory usage and the database usage. So this is the user interface of the system. It has 5 tabs. Different users can access only a subset of the tabs. For example, the administrator can access all the tabs, and the teacher can access the topic, the NAPs, but it cannot access the NetNodes net tab. So for teacher can create topics and import NAPs. So the teacher can create a NAP from the existing Docker image and add a tag lab to the topic. For example, the reliable data transmission topic, it contains 2 NAPs, the go back N experiment and the selected repeat NAP. So there are 2 NAPs in this topic. And for teacher, it can release a lab on the to the students. And before it can release he release a tab lab. He can configure the metadata of the lab. For example, he can add the title of the lab and describe the lab, and it can specify the deadline of the lab and add the tutors to the lab. And it can also allow a range of IP address of the client to submit the lab. And for student can enroll a lab. For example, student can click this link to enroll himself to this lab. And in this box, the student can type his code or paste his code and submit to the lab for the system to evaluate. And the student can view the evaluation result. So there are 9 results. The accept is that the code is okay. The code is okay, and partial accept means that the code passes some test cases but failed in some other test cases, and there are other status code. And for the teacher can view all the evaluation results. So this is the teacher can review all the results. And for the administrator, the administrator can view the source usage of all the OpenNetLab nodes. So for example, there are 2 nodes, and this is the CPU usage, this is memory usage, and this is the last heartbeat. If the last heartbeat is long ago, means then this node may be offline. So I'll introduce an example to show how this system works. So we look at the go back N protocol. This protocol is also known as sliding window protocol. And in this protocol, the sender sends data to the receiver, and receiver returns ACK. And if some ACK is missing, which means that the packet loss, the sender will wait for a timeout and resend all the ACK, not ACK packet again to the receiver. So this is a very simple mechanism in the network, but this is also very important as is part of the principle in TCP, in current TCP TCP stack. So we want students to implement go back and cinder. So here is how we realize this NAP. So we use two execution codes. One is sender and another is receiver, and we prepare some codes in Docker images. The receiver is provided by the NAP, so students need to realize the receiver, and students submit code to realize the sender. And both nodes have some basic functionalities such as send and receive packets, and encapsulate and decapsulate packet with the ONL protocol. So remember we have a ONL protocol, and the system, the sender maintains the timer, and the student can simply start a timer, stop the timer, or receive a timeout event, and both nodes keep the logs. So this is the finished state machine of the sender, and this is the receiver, and we want the student to realize this FSM and the sender part. So how teacher can deploy this NAP to the student, can release the NAP to a student. The teacher can select the basic NAP. So we have a Docker image for this NAP. A student can select the basic NAP, download the Docker image, and obtain the code, can decompress the file and obtain those files. And then it can select how many nodes to run for this NAP. For example, in this page, the teacher specify there are 2 nodes, and each node they can specify the port number on each node to run this NAP. And for the teacher, you can also specify the details of the NAP. For example, it can specify the timeout, how long is the timeout, and the packet loss probability. For example, 0.1, and the maximum delay. So each packet before you send out, it may be delayed for random period of time. So sometimes some packet send earlier, maybe arrive later, and some packet send earlier, maybe arrive earlier. So this introduce out of order packet reception, and there are some other. This is a test case. So this is a string, and each packet carries 1 byte of this string from a sender to the receiver. So there are some other parameters for the teacher to specify. And what the student need to do? The student we provide the student pseudocode like this. Student need to implement 2 functions: the send message and the timeout handler. So they submit 2 Python functions in a box. And in these 2 functions, the student need to implement a few things by himself. For example, assign a sequence number to the packets, and maintain a sliding window, and send and buffer data, and wait for the ACK. And the student also need to handle the timeout and handle the ACK. So all these things the student need to implement himself. But the timer, and the student need to implement a timer himself. The lab provides a timer. Student can only need to start timer and stop timer like this. And so we can see how this NAP works. So for the sender node, after the student has uploaded his code, the sender send 1 byte per packet, and the sender node read the teacher's configuration in this page and simulate an unreliable channel, and it introduce some losses, introduce some delays, and so here we will see some packets are lost, and some packets have out of order transmission. And for the receiver nodes, the receiver nodes are provided by the NAP, and it will send ACK for the correct received packet with the highest in order sequence number. And it will also evaluate how the students resend the lost packet to the receiver. It will keep the log and use this log to evaluate how correctly the student have implemented this mechanism. And it will also generate multiple test cases to test the student submitted code. So here we can see an example. So this part is the code submitted by the student. It's a correct code, and we can see we use three test cases to test this code, and this code passes all the 3 cases. And this is another example. In this example, student only submit a run code, and this code passes only 1 test case and fails in other 2. So this result is partially accepted. So this is how we evaluate. We automatically evaluate the student submitted code. So in summary, we have developed this is example, and we also developed 3 labs. For example, we have developed 3 labs. One is GoPagan, and we have just introduced. Another is selective repeat. So this is another reliable data transfer protocol. And the third is the DNS relay and filter. So in this lab, we want students to implement some DNS relay program and filter some domain names. So the system contains web tuple, controller node, and execution node. All these are on OpenNetLab platform. And if a teacher wants to use this use these labs, it can just join this community and can directly use the labs. And we are still developing more labs to add to this project, and we want our colleagues to use this lab in your network education in your course, and we also want the colleagues to contribute more labs to this project, because the more the more labs we have, the better we can make use of the resources. And actually, currently this system is used in the undergraduate computer networking courses in Nanjing University and University of Science and Technology of China. So that's all. Thank you.